Hello and welcome to my channel. For today's video, we will be discussing some of the application of a rational function, which is word problems involving rational functions. That covers different areas you might be familiar with. So let's start right away after this short intro. Okay, let's start with the problem number 1. Thor and Loki can complete a job in 4 hours if they work together. Individually, Loki requires 6 hours more than Thor to do the job. How many hours does it take Thor to do the job if he works alone? So for this particular problem, we are dealing with work problems. And this is the formula that we're gonna use for this particular one. Rate of work times time worked equals part of task completed. And let's have a table just to be more organized. Then let's assign the first row for Thor and the second row for Loki. So let's have this one. This is for Thor and this one is for Loki. And then let's fill in all the boxes with all the information that we can get from our problem. So rate is equivalent to the portion of one particular job over a period of time. So that means for Thor, we have 1 over, since it doesn't mention here on the problem how much time did Thor work for this particular job. So let's write X for this one. And then X represents the time our Thor worked for this particular job. And then for Loki, we have 1 over 6 plus X. Since based on the problem, Loki requires 6 hours more than Thor. So 6 plus X. And then for time, let's use the information 4 hours since they are working together. So let's use 4 for that. And then for the column T, we will be using this formula. So rate times time is equal to the portion of the task completed. So that is 1 over X times 4. And we have 4 over X. And then for Loki, let's just simply multiply that. So the result would be 4 over 6 plus X. And then from there, we can create an equation. Okay, so for this type of problem, remember, if the two can work together, they are finishing one particular job. So let's use that information. So we have 4 over X plus 4 over 6 plus X equals 1. And then to simplify this one, we will be multiplying this to their LCD, which is X times 6 plus X. Okay, so let's have the column for that. And then let's divide and multiply this inside the parentheses. So the LCD divided by this one, we will cancel X and then we will be left with 6 plus X times 4. That gives us 4 times 6 plus X plus, and then we will do it again. X times 6 plus X divided by 6 plus X, we will be left with X times 4, that's 4X, equals the LCD. X times 6 plus X, since we will be multiplying it by 1. And then from here, we will simply simplify this by simply distributing this number inside the parentheses. So 4 times 6, we have 24. And then plus 4X. And then plus 4X again. Equals X times 6, we got 6X. And then X times X plus X squared. Then let's simplify this term, combine like terms. 4X plus 4X, we have 24 plus 8X equals, let's simply rearrange this one, x squared plus 6x. And then let's move every number to the other side so that we can get an equality that is equal to 0. So we have 0 equals x squared plus 6x minus 8x minus 24. And then from here, we can combine this term. So we have x squared, 6x minus 6x, we have minus 2x, minus 24. And then we have a quadratic function. We can now factor this one. X divided by x, we have x times x. And then to get negative 24, we just need 6 times 4 for that. And then if we're going to subtract or add these two numbers, that gives us 2, negative 2. So since this is a negative number, let's use negative 6 and then positive 4. And then we will simply equate these two factors to 0. So x minus 6 equals 0. And then x plus 4 equals 0. This will give us the answer, x minus 6, x equals positive 6, and then this is plus 4. So this gives us x minus 4. So since we are asking to find how much time does Thor do the job if he works alone, since we are asking for the time, we will simply neglect negative 4. Okay, since there is no negative number when it comes to time. So the only number that we can accept is simply x equals 6. So how much time did Thor do the job? So that means 6 hours. And this is our answer for the problem number 1. Let's proceed with the question number 2. Okay, let's have the problem number 2. 2 hydrous water pipes can fill a tank with water in 6 hours. The larger pipe, working alone, can fill the tank in 9 hours. How long will it take the smaller pipe, working alone, to fill the tank? Okay, so again, this is another word problem. So again, let's have a table for that. And then let's assign the first row for, say for example, larger pipe, and then the second row for smaller pipe. And then for R, we know that the larger pipe working alone can fill the tank in 9 hours, so that is equivalent to 1 over 9. And then the smaller pipe, so it's not been mentioned, so let's use simply 1 over x. Since 2 hydrous water pipes can fill a tank with water in 6 hours, so both pipes, so it's the same with problem number 1. Let's just use 6 for that. And then simply multiply the two numbers. So 1 over 9 times 6, that's 6 over 9. And then 6 over x. And then from here, we can generate an equation once again. So 6 over 9 plus 6 over x equals 1. And then simply multiply both sides by their LCD, which is 9x. So 9x divided by 9, that is x times 6, we have 6x. Plus 9x divided by x is simply 9 times 6, we have 54. Equals 9x. Then from here, we can combine like terms. So 9x minus 6x equals 54. So 3x, 9x minus 6x, we have 3x equals 54. And then we can divide both sides by 3. (54) divided by 3, so cancel this one also. We will just simply left with x equals 18. Okay, So the smaller pipe working alone can fill the tank in 18 hours. And that is our answer for problem number 2. Okay, so let's now have problem number 3. Captain America drove his motorcycle running a 150 kilometer on country roads before driving 50 kilometer on a mountain roads. The rate of speed on a country roads was 3 times the rate on the mountain roads. The time spent traveling the 200 kilometer was 5 hours. Find the rate of his motorcycle on the country roads. Okay, so let's have again the table. So we have a different notations here. It's because we are dealing now with distance problem. So the formula to find the distance problem from your physics class was d, or distance, is equal to rate times time. Okay, and now we can now assign the first row. Say for example, this is assigned to the country roads, and then the second row for the mountain roads. To find the distance, we have here mentioned in our problem 150 kilometer on the country roads, and then 50 for the mountain roads. And then to find the rate of speed on the country roads was, so for the country roads was 3 times the rate on the mountain roads. Since there is no particular rate for the mountain roads, we will simply represent that, say for example, R. Okay? And then for the country roads, that's 3 times the rate on the mountain roads. So 3 times R. And then for time, we have to somewhat derive the formula from our original equation or formula. So this is T equals D over R. Okay, so let's use this formula to find T. So that is distance 150 divided by 3 times R. And then on the mountain roads, we have 50 divided by R. And now we can get an equation from here. So we have 150 over 3R plus 50 over R. So the combined kilometers that they cover was 200 based from the problem. And then that is also equivalent to 5 hours of travel. So equals 5. Okay? So before we multiply by their LCD, let's simplify the first term first. So 150 divided by 3R, simply 150 divided by 3, that will give us 50 over R plus 50 over R equals 5. Okay? And now we can multiply by the LCD, which is simply R on both sides. So R divided by R is simply 50. So cancel. And then R divided by R is just simply another 50. Okay? And then 5 times R is equal to 5R. And then 50 plus 50, that gives us 100, equals 5R. Divide both sides by 5. R is equal to 20. Okay? So now we have the value for R. But if we're going to back to our problem, R represents the rate of the motorcycle traveling on the mountain roads. But we're looking for, on our problem, find the rate of his motorcycle on the country road. So we have to multiply this one on this portion, 3 times R. So 3 times 20, that gives us 60. So therefore, the rate of his motorcycle on the country roads is 60 kilometer per hour. And that would be our answer for question number 3. Okay, so let's have problem number 4. A boat can travel 9 km per hour in still water, can travel 15 km with the current in the same time that it can travel 10 kilometers against the water's current. What is the speed of the water's current? Okay, so we have the same notation on our table, but this particular one, we are dealing with the uniform motion. Since there is a factor that affects the rate of movement or motion of a certain vehicle. So this time, we're using both. Okay, so let's assign the first row for with the current, and then for the second row against the current. Okay, so the distance covered with the current is 15 kilometers, while the same time travels 10 kilometers for against the current. And then the rate, since they have given the same rate, 9, and then 9, since this current or rate is affected by the current, so since we're looking for that, so that is with the current, so 9 plus x, and against the current, that's 9 minus x. And then we will use the formula T is equal to D over R, so that's 15 over 9 plus x. And then we have 10 over 9 minus x. Okay, so if we're going to analyze the table, they are running at the same speed, 9 kilometers per hour. And they are using the same time, as you can see from the problem. But if we're going to compare the distance that they covered, they are different. It's because the boat was affected, or the speed of the boat was affected by the current. So this is why we call this problem uniform motions. Okay, because they are using the same speed. Okay, so since they are using the same time, we will be equate both sides by itself. So 15 divided by 9 plus x equals 10 divided by 9 minus x. So to solve this kind of problem, we will just simply cross multiply. Okay? So we have 15 times 9 minus x equals 10 times 9 plus x. Okay, so 15 times 9, that is 15 times 10 is 150 minus 15, that's 135. Minus 15 times x is negative 15x. Equals 10 times 9, that's 90, plus 10x. Okay, so let's combine like terms. So let's proceed this on the other side. And then on the other side, we have 135 minus 90 equals 10 plus 15x. So 10x plus 15x. So our answer becomes 45, excuse me, equals 25x. So let's divide both sides by 25. So we have x equals 45 divided by 25. That becomes 9 over 5. Or we can use decimal number for this. X is equal to 1.8. So we can now answer the problem. What is the speed of the water's current? So this time around, the speed of the water current is simply 1.8 kph. And that should be our answer for question number 4. Okay, so let's move on with example number 5. The denominator of a fraction is 4 more than the numerator. If both numerator and the denominator are increased by 3, the new fraction is 5 over 6. Find the original fraction. Okay, so the denominator of a fraction, we have the numerator and the denominator. So it's 4 more than the numerator. So that's 4 more than, that's plus. And then we don't have the number for the numerator. So let's represent the numerator as n. Okay? So for the denominator, that's 4 plus n. And then on the second condition, if both the numerator and the denominator are increased by 3, so let's add 3 on the numerator and add 3 on our denominator, the new fraction becomes 5 over 6. So let's add both them. So n plus 3 divided by 4 plus 3 equals 7, or n plus 7. The answer is, or the new fraction is 5 over 6. So to solve this problem, we can simply cross multiply. Okay? So we have 6 times n plus 3 equals 5 times n plus 7. And then distribute this number. 6 times n, that's 6n. 6 times 3, that's 18. Equals 5 times n, that's 5n plus 35. And then let's just simply combine like terms. So we have 6n minus 5n equals 35 minus 18. Okay, so 6n minus 5n, simply n. 35 minus 18, that is 17. Okay, so we have the value for n. Let's replace n with our number. So n over, or simply 17 over 4 plus 17, that's 21. So let's check if the answer is 7 over 21 by simply adding 3 on the numerator and 3 on our denominator. That should be equal to 5 over 6. Okay, let's check if the answer is correct. 17 plus 3, that gives us 20. 21 plus 3, that gives us 24. And then if we're going to simplify, 20, that is equal to 5. Divide both sides by 5, or both numerator and denominator by 4, rather. Okay, if we divide it by 4, so 20 divided by 4, that's 5. 24 divided by 4, that's 6. And then 5 over 6 is simply 5 over 6. Therefore, our answer is, the fraction is 17 over 21, or that's the original fraction. Okay, moving on. Okay, so last example. When the reciprocal of the number is subtracted from 1, the result is 3 times the reciprocal of the number. What is the number? So when the reciprocal of the number, so the number, say for example, is n or x. Okay, so this is the number. So let x be the number. Okay, and then its reciprocal, the reciprocal of x is simply 1 over x. So we have now the number and then the reciprocal. But this is subtracted from 1. So let's have an equation. So 1 minus 1 over x. The result is 3 times the reciprocal of the number. So that's 1 over x. So we have an equation. So we can simplify this term first. So we have 1 minus 1 over x equals 3 over x. And then from here, we can multiply by the LCD, which is x. Okay, x times 1, that's x, minus 1. So x divided by x, cancel, so we have times 1, that's negative 1. And then on the other side, let's divide x by x, that's 1 equals 3. And then let's move this number to the other side, so we have x equals 4. Okay, so let's check if the number is 4. Okay, so when the number when the reciprocal of the number is subtracted from 1, so let's use that. So 1 minus the reciprocal of 4 is simply 1 over 4. The result is 3 times, that's 1 over 4. And then let's use this equation, 1 minus 1/4 equals 3/4. Okay, simply 1 minus 1/4 is simply 3/4. So therefore, we satisfy our equation. And so, since we satisfy the equation, the number is simply 4. And that is our final answer for our question number 6.
Thank you for watching. If you are still new to my channel, please press the subscribe and notification bell to be always updated to all my upcoming videos. Thank you. Always at your service, Sir Absolon.
Sa iyong ngiti, ako'y nahuhumaling. At sa tuwing ikaw ay lalapit, ang mundo ko'y